Welcome to this video. This will be a short video on the very interesting topic of AI agents. So I have been trying to understand this for a while now, and I've been, doing research and reading, and basically, I think now after going through this for a while, I have a very clear understanding of what AI agents are. So that's what I will be talking about in this short video. So the short video will include a definition of what AI agents are. This is the definition by Anthropic. There's actually several definitions that are going around, but there seems to be a consensus. And so I want to talk a little bit about this. I also want to point out that I put together a GitHub repo. So in my GitHub, if you go to Agents AI, you can see the URL there, right, to Agents AI. And I have several examples that I've been studying, several articles on AI agents. But I think, and I'll cover some of these in future videos, but I would say that the one that made AI agents click for me was this one, the Leopard Arts um, example. So I will go over it. As you can see, it's pretty short. And so I want to talk a little bit about it. So for this example, we'll be using the SMOL agents library, small agents library from Hugging Face. This is a library that recently came out. It's very impressive. This is actually like the third iteration from Hugging Face dealing with AI agents. But I think it's a really good one, very interesting. And also, because we are going to be using this library, we're going to have to use, like an API for Hugging Face. So that means we're going to need to use, you need to, if you want to replicate this, you would have to have an account with Hugging Face, create an account there, and then just get the access token. So I will discuss that as well. So how to establish that connection. I know for me, when I was trying to get this going, just getting the tokens sorted out was a bit of an issue. So I wanted to go over. So the first thing I'll do is basically the definition of agents. All right. And it's very interesting because even Anthropic has had a lot of experience building agents, building agent workflows. And so coming up with a definition of what AI agents is has been difficult, but I think they have a really good one now. They basically advise that, an AI agent is not for everything, right? So there are situations where, an AI agent is important, and there are other situations where you just have like basic code, and that's kind of what they call workflow. So let's go over the definition. So what are agents? Agent can be defined in several ways. Some customers define agents as fully autonomous systems that operate independently over extended periods using various tools to accomplish complex tasks. Okay? Others use the term to describe more prescriptive implementations that follow predefined workflows, right? A more fixed, static approach. Anthropic, which is one of the big companies similar to OpenAI, so at Anthropic, they categorize all these variations as agentic systems, but draw an important architectural distinction between what they called workflows and what they call agents, which is the term that is the buzzword currently. And I really like this definition. So workflows are systems. So workflows are not agents, right? They are agentic systems, but not agents. So workflows are systems where an LLM, a large language model, and tools, so imagine an LLM and tools, are orchestrated through predefined code paths. And the key word here is predefined, all right? Very, fixed, predefined. Agents, on the other hand, are systems where large language models dynamically, so notice the contrast between predefined and dynamically direct their own processes and tool usage, maintaining control over how they accomplish tasks. So this is when, agents are in for, they recommend for situations where there's some kind of a evaluation of the data and a decision can be made. So they can dynamically decide, okay, I need to take this direction, I need to tool use this tool. So I've been thinking about this idea of agents as I look at the code. And one analogy that I'm currently using is this analogy of a marine biologist. So if you think of a marine biologist, right, and think of as a person, that person wants to go into the ocean to deal with whales or something, and maybe, you know, take a sample and, you know, and inject them with something, etc. So what needs to happen there? So we have the human. That human needs to go into this environment, which is the ocean. So to be able to go into the ocean, they're going to have a oxygen tank. They're going to have like a wetsuit, snorkels, radios, probably, etc. Right? So that is an environment that needs to be wrapped around the marine biologist. And then once it has that, the marine biologist also needs to have tools like a sensor, a probe, an injection, etc., which are the tools that they're going to use to be able to treat the whale in the ocean. So I've looked at the code and I kind of like to think of that analogy because the way that that translates to, large language models is I would say the marine biologist is the LLM, but that LLM needs to interact in some environment, and so that is something that is going to be provided by something like the small agents library from Hugging Face. It's a wrapper code that allows you now to interact with several things in an environment. And then finally, that code wrapper around the LLM agent will use tools, and it can have basically a list of tools that it can use. So it can have a tool such as to generate images. It can have a tool for looking up things in Hugging Face. It can have a tool for actually searching, the web, right, to perform information. So those are the things that I would say are really important. So with the analogy, you have the LLM, you have the wetsuit, which is the code wrap around the LLM, and then you have the tools, which can be, whatever you're going to use. All right. So anyway, so that I think is a good definition of an agent is something that dynamically, where LLMs dynamically direct their own processes and tool usage. All right. So now that we have this kind of concept and an analogy, let's look at a concrete example that can give us a better understanding of this. So this is in my GitHub, as I indicated. You can see that the notebook there. You know what? Right. So you can also, I guess, find this at my website, calix.com. So you can go there, just hit on GitHub, and you'll find AI agents. All right, so let's go back. So we're going to do this example. This example is actually really simple, but one thing that it will require is for you to use the small agents library, and you're going to interact with the Hugging Face hub, right? And so think of it as making an API call. So you're going to need to have tokens, a Hugging Face token to connect. If you want it, now this small agents framework actually is very powerful, and Hugging Face has provided this other library called Light LLM, or this library is available, and you can use that one in a similar way to how you use SMOL agents, but you can use this one to connect other models from other sources such as OpenAI, Anthropic, etc. So in a future video, I will probably do an example where we use GPT 4.0 or 4.0 mini using light LLM to kind of and small agents to kind of illustrate how AI agents work. But in this example, obviously that option costs money, right? Because you have to subscribe to OpenAI. This option of small agents and connecting to the Hugging Face is basically like when you go use the Transformers module and you download models, for whatever you want to do. So it's similar. So this one didn't cost me anything to do, and it shouldn't cost you anything to replicate. All right. So basically this is going to be the code. And before I get into it, I just want to stress, the tokens part. So what you would do is you would go sign up to Hugging Face, just Google Hugging Face token access, create a token, copy it. And once you have it, I'm assuming, here I'm using a Mac. And so I would have a terminal. As you can see, I have my base environment with Anaconda. So here I would do Conda, activate, and then Pi. It uses 3.10, by the way. So Python 3.10 or greater, right? So I assume that's already created. So I would activate that environment. And then once that's activated, all you have to do is you have to run something like this. So export HF token, which is your environment variable. And of course, this here would be the token that you would get from Hugging Face. Just do that, hit enter, such as that. And then once you do that, you can run Jupyter Notebook, for instance, start it up, and that's it. Then from your code, you can retrieve the token from your environment, and basically that's it. So I will show you how to do that. All right, so this is a great example. This is from the Hugging Face website. They provided this leopard at Pont de Arts. So, what is Pont de Arts? What's the problem? So here, basically, the only library you really need for this example is smolagents. You see the command to install it. As I showed you, this is the command to export the key, right? And as I just showed you, and then after that, you just start the Jupyter Notebook. The way that you retrieve a key that you've added on the terminal, like in my example, would be something like this. So you will use the OS library, and then you do os.get environment, and then basically the access token. So in this example, I'm showing actually how to load the OpenAI key, but it's basically the same. You can load as many keys as you want also. All right, so now that all of that is out of the way, let's get into the meat of AI agents. So basically, what do you need? You import the OS, and then basically you grab the OS get environment variable, HF token, which we just added, and you just assign it to something like OS environment, HF token. That's it. So with that, you shouldn't have any problems connecting, etc. Now, what we're going to need is obviously to use the new library from Hugging Face, smolagents. This is really nice. I believe this is like their second or third iteration attempting how to implement AI agents. And this one, I do like this one a bit, so more than a bit, I should say. It seems very streamlined. So so it's got obviously several things, but here you can think of this code agent basically. So from smolagents, you're going to import really three things, okay? And this is kind of what goes back to my analogy of the marine biologist. So in the analogy of the marine biologist, I said there were three things. There was the person, that's going to be the model. So HF API model is what you can use to grab a model. And it has a model by default, which is Quen, but you can use other models as well. So this would be the person in my analogy. The wetsuit and oxygen tank would be this one code agent. It's like the wrapper around the agent. And then finally, the tool, the injection or the sensor would be this. So in this case, you can see DuckDuckGo search tool. Now, this is a built-in tool in smolagents, but actually, as it turns out, very interestingly, you can create your own tools, which makes you think, right? In the future, you might have lots of agents and people will develop tools and they'll be sharing these tools, or maybe they'll sell these tools and it'll, a new industry. So there you go. A new AI industry will probably arise from something like this. So once we have grabbed the libraries, then the next step is to instantiate basically our agent. We use code agent, the code wrapper, which will basically take a parameter called tools, to which you provide a list of tools. And this doesn't just have to be one tool, but it's several tools that you're saying to the agent, hey, maybe for this problem, you should use this tool. And then, of course, we provide the model, which in this case is just Hugging Face API model. And as I said, keep in mind, we're just using the default Quen. If you wanted to use another model, you would put it within the parentheses. And that's it. You do all of that, and you now have a AI agent. So the key thing now is it's going to dynamically try to solve a problem. So in this example, I'm going to take agent.run, and I'm going to give it a prompt, right? So if you look over here, I'm going to give it this prompt that says, how many seconds would it take for a leopard at full speed to run through Pont des Arts? Okay. So obviously the agent is going to look at this and is going to start wondering, okay, well, the obvious thing, what is Pont des Arts, right? So what is that? Okay, so it needs to understand that it's a leopard, and we're talking about how long it would take to run through it at full speed, several things. So basically, the agent is going to start trying to solve this problem using its tools, right? So here you can see it starts to kind of like think about things. So you start a new run with the question, right? You can see that here, right? So this is using the Quen model, although it's not specified. If you run it, it'll say that. And so basically, you ask the question, and you can see that in the way that the code agent has basically these prompts, like built-in prompts that they've specified so that when given some text, it's like instruction, it's an instruction set. Quen is an instruction, 32 billion LLM. So it'll basically try to understand what you've provided through the prompt and then extract information from it. So it's already started to do that, right? So it extracted basically correctly that Pontus Arts is a place, right? And it needs to know the length of it because it needs to know how long it would take to for a leopard to run through it at full speed. So it's already identified a variable for it. Notice also that it's that the agent is kind of thinking in Python. So it's starting to write a Python code that to try to solve this problem. Notice also that it uses web search, right? So web search, we gave it basically the idea of using DuckDuckGo, the tool. So it's using tools to do a web search. What the query is, the length of Pandas arts. So you can see here, basically, it does the query in the search engine, and it starts to query things like Wikipedia, etc. And if you look, one of these does contain the length of the bridge. It's a bridge actually in Paris. So it has 155 meters or 509 feet. Once it identified that information, then it needs to also figure out the speed of a leopard. Notice that it got that information as well. Leopard speed results. It uses a web search again. And basically, the query is, it was able to extract that what it needs is top speed of leopard, right? So this is the functionality of both the LLM and the code wrapper working together. So now it starts extracting information. Notice here, African leopards have a top speed of 50 to 60 kilometers per hour. So it's starting to get that data. So now we can see here that it extracted the information correctly. So it's found that the Pont des Arts has a length of 155 meters. And notice that it's writing it in Python code. And notice over here that it also found the leopard top speed in kilometers per hour. That's 58. Notice that it understands that this is in meters, this is in kilometers per hour, so it needs to make the conversion to meters per second. So it figures that out as well. And then finally, it just does the final calculation. Pont des Arts length divided by Pont leopard top speed, ms. And that's it. So once it does this calculation, whether it gets it right or wrong, it's pretty impressive how it works. It concludes that the final answer is 9 seconds, basically. So this is basically, that concludes the example. As you can see, this is an agent answering a question, performing reasoning. What's important about it is being, it's a LLM the Quen LLM being used in the small agents environment using tools to kind of, you know, perform a task, dynamically. It was able to solve the problem by doing this and doing that, and then taking that information, making decisions, and arriving at an answer. All right. So that basically is the example that I wanted to cover to explain what AI agents are. I think for me, this was a really good example that allowed me to really grasp the concept. In future, obviously this is it's not performing tasks, but you can imagine it's writing Python code here, so you can imagine how it could start writing Python code that becomes cron entries for a Linux operating system, or it becomes functions to control the operating system. It could use OS, right, subprocess, etc., and start running commands on the terminal. So you can see how it could start to take action. So in a future video, I might cover something like that. This is a simple one example I wanted to give on what AI agents are and how they work, which I thought was really good for me to understand the topic. All right, so that's it. I hope you enjoyed the video, and I will say goodbye here.